Good afternoon. How's everyone doing today? It is not spring anymore, but still love the intro. Good to see you here. Miles, Anna in the chat, Veda in the chat, Kevin in the chat, Wilton in the chat. Good to see you here. Let's throw another 50 points the chat's way. How is everyone doing today? Now, one of the biggest things, I'm too afraid to look. The UT Knoxville at the end is, oh, thank you so much, with the Nintendo logo thing right there. I got to re-render where it says what semester it is, just because every semester I have to update that, and I've used it for 2 semesters now. I lost by less than a point in fantasy last night. Rip, no. I won. I felt so bad. One of the people in our group, obviously, I beat, and so I don't feel super bad. But let me go down here to fantasy. Yeah, it's been a good week, and lots of stuff right here. People are talking in the fantasy league. So if you want, the Discord's been doing great. Who's been using the Discord to get some help lately? Long night of studying. Yeah, it's been a lot going on. A lot of tests going on. One known fantasy. Shout out Cooper Cup right there. Yeah. Awesome job in the fantasy right here. My fantasy team's doing all right in both my leagues. So pretty good, but you never know. You get injuries or someone starts popping off in a season. Pretty crazy. But what's going on? Yes to the Discord. Yes. Discord helped a lot on Sunday. So please, if you can, post all your questions in the general chat. That's a great way to help out. Shout out to my team that has Kelsey Hill. Oh, what's his name? Trevor Kelsey. My brother has him. Great tight end right there. First round pick, obviously. The Discord is a huge help. Join up on the Discord if you haven't already. Post your questions in the Discord, and the general chat is a great way to help out others. Just be like, hey, how do you do this? How do you explain this? What's going on right here? Because we want everything to be a strong learning experience. I'm not against GroupMe, but it's a great way of putting it, right? We'll throw out 100 points right here for Brian not liking GroupMe. Why does Brian not like GroupMe? I think the biggest thing is, let me ask you this. What do you generally see people using GroupMe for? Learning material, getting answers. Of course, I could ask this about Discord too. Other. Okay. What do you generally see people using GroupMe for? Of grids, GroupMe is the child sharing information. So I kind of put it in a nice way, getting answers, which people could say that about our Discord probably too. Like, I'm gonna ask it. Don't worry, I'm not gonna go after anything here. If there's a GroupMe for this, I'm not trying to. Frankly, the amount of time I spend looking to, I dedicated a whole weekend this summer to cheating, not on purpose, but I had to look through stuff. GroupMe are kind of fire to be. You got to send me some of those, Wilton. You got to send me some of those general questions about class, test times. That's good right there. Alyssa, that's good stuff. That's what we want. That is great stuff. Difference between getting answers and getting help to understand concepts. Exactly. And so that's why I want Quizlet is the study equivalent of GroupMe. Yeah, and I think Quizlets are great. I fear, and I'm just being as honest and transparent as I can be. Here, we'll end this poll. And so this is your point. I can't see who votes what, so I don't know if you're voting for or against. It won't let me do a new poll yet, but I'm gonna do a new poll. I'm gonna ask a question right here. Do you think people use GroupMe to cheat? I really want to do a big survey on this. Do you think GroupMe? Let me ask it this way: GroupMe has a large cheating problem. Do you think there's a large cheating problem with what goes on GroupMe? Definitely. Oh my gosh, you naughty Brian. Maybe. Don't think so. No. You've got the 3 choices right here. Do you think GroupMe has a large cheating problem? I just want your insights. Parker says he's not in GroupMe's typically. So do you think GroupMe has a large cheating problem where people are going on to GroupMe's to cheat? Definitely. Maybe, I don't know. Maybe I've seen it, not really. And, or no, I really don't see that. I don't see GroupMe being primarily used for that. So we'll see what people say. It looks like maybe's winning out right here. I mean, it just depends. It depends what class you're in. It depends who's doing stuff. I think a lot of the cheating goes on, at least when I've been catching people, usually goes on in a private message. People can confirm or deny that if you want, because usually what I hear is somebody messages someone and says, hey, I'm in the GroupMe with you. Can you send me this work? Usually it's more of people don't want to put it out there in the public on the GroupMe. They want to message someone who's in the GroupMe. So it's almost like they connect through the GroupMe, but then it's not in the GroupMe that it happens. It's usually outside of it. It always depends on the class. If it's a gen ed, it will 100% have people cheating. Oh, man. See, that's the bummer. That's the bummer with Whitson right there. And it's just the thing about cheating is if you cheat in 320, 474 gets way more difficult. If you cheat in 474, 475 gets more difficult. You know what then sucks really bad? If you cheat in 320, 474, 475, 479, all those things, yeah, I mean, there's a lot of clicker. If you cheat in all your classes in business analytics, you come out with a degree that you don't really understand to get a job in a field that you don't really want to do the work in. And then you're just like, well, I got this degree that I don't really like, that I don't want to do the work in, that I don't know how to do the work in. You can't do your job. You don't want to do your job. And you're like, I don't like this stuff. So I think if you are cheating, I mean, it's like you're just cheating yourself, but you really walk down a path where the further you go into not doing your own work, the harder school becomes, and the less you're gonna like what you're doing, because it's just, you're not gonna understand it. So it's a bummer. And so I just want to give you the encouragement right now. Give you the encouragement to productively work together. And I really like the Discord for that reason. So shout outs to the Discord. If you're in a group me and it's going great, keep doing what you're doing. Keep doing what you're doing. If you got a group me, that group me's going great, definitely keep doing what you're doing. Someone's going to teeth their way through BAS and sit and wait. No, Max, that seemed like a good response. I'm throwing Max 100 points. I want to read what Max, I wish I could have saw that. Max retracted that so quickly. Max, that 100 points goes out to you right here. That 100 points goes out to Max right there. I think I sent the announcement to all the sections. I'll tell you, it's like I blink and my mind resets. What's that thing, like a shrimp or something? The shrimp's mind, it just like can only keep one thought in it. That's the way my brain goes at times. Let's load up the notes right here. We've had our little pep talk to start out class. Typo, but yeah. Best scenario you could do, be Bernie. Oh no. Sitting Microsoft as a 22-year grad, Googling, what is it? Oh, man. Oh, that would be... And it's understandable. I Google things all the time. You go to Stack Overflow. I bet you people all the time are going to Stack Overflow at Microsoft. Any sort of company that has coding, if they're not going to Stack Overflow, they're not challenging themselves. So the reason things like Stack Overflow exist is because you want to push yourself. You want to go to that next level. Literally, coding is just training your brain muscle, brain's a muscle, to get stronger and smarter and to do harder things. And you only do that with progressive overload. Little training montage right there we need. But with that, you only do it. Can we get a Puppet Shark? You bet. Some Puppet Shark right here. All the exams. We've even got a new thing. I'll show you the new thing right here. I'll make sure I got the notes up. A little too late, though. Let's go over to the notes. What exam next week? Horrible exam week. Yeah, it's just exam week for a lot of people. A lot of exam weeks coming up right here. Puppet Shark helping out. We're going to go back in here. Last time we were talking about p-values. Oh, man, today's a bit of a fun day. Let's go back here talking about the p-value. Or you even just forget the syntax. Exactly. If you're working with multiple languages, you're going to forget some syntaxes. I have 4 exams for different classes this week. Megan, this 100 points goes out to Megan right here. Let's start the week off strong. Here we go, hopping into some notes. Get our 5-10 minute pep talk out of the way. We do have something new off the show on the main screen. I added something today, but it's not on this screen. Who can explain what this red line is? You need to know what this red line is. It'll be in a lot of your graphics. What is this red line right here? What is this red line right here? So what is that red line right there? What is that? What does it represent? We're looking at a permutation procedure. And Wilton, you're right there. Some 20 points in the chat. That is our discrepancy. That is our observed discrepancy. These discrepancies over here in the green are all discrepancies created by what? All of these discrepancies in green are discrepancies what? So this is our observed result, like it's how much of a discrepancy we observe. We observe a very large discrepancy, which means the boxes are going to look pretty far off. Those are the ones created by random chance due to permutations, which are just randomly putting the data together. So when we randomly put the data together, we get these random permutations, and then we look at our results. And what do you notice here for the results that are as extreme or more extreme than our results? What percent of the data, which I can't even really do this, but what percent of the data is as extreme or more extreme than our result? What percent of the data is as extreme or more extreme than our red line right there? If you look at the random permutations, and what did we just find, Veda? Andrew, Veda, great answers right there. What did we just find? Now, it's not R, it's not going to be R, because that'll be correlation. It's going to be a what? Very close to little p, q, r, little p. It is 0, and we just found the what, because we found the probability of our observed result. Great job, Max, right there. Think about this. The probability of our observed result or a result more extreme occurring by random chance variation is 0. Basically, we're saying what we observed here is very what due to random chance. The discrepancy we are observing here between the boxes, and the discrepancies look something like this. It's how far apart these are. This discrepancy we observe is very, very what due to random chance. The greens are the random chance if we just randomly permutate them and just move them around and just say, oh, let's do it. Very unlikely due to random chance. Exactly. And that means it is what? Last word right here. I'm throwing 100 points. Everyone's on track right here with these answers. Has a very small, it's super improbable. Means it's very, very, people said p-value less than 0.05. That means it is what? Keyword. We have found that this result is what? Statistically significant. And that's when the p-value is less than 0.05. So we're saying here that these differences between the providers, where we're looking at which ones have the dropped calls, we see a statistically significant difference that is unlikely by random chance. Let's say you're a super important business type person, and you want to make sure your cell phone does not have dropped calls. So now you're going to probably get what company, which Brian doesn't have. He's not a super important business person. If you want to make sure, how would you use this information as a practically significant way to decide as a super important business person? That's the sign of super important business. To make a decision on which cell phone provider to take, given the practical significance of these differences. Verizon right there. Brian's got AT&T. Brian is not a super important business person. So you're going to pick Verizon if for some reason drop calls are very important to you. And I think Verizon generally has a higher cost. If they do a better service, they could charge more. I think I've heard usually Verizon has just a better signal. And yeah. Does this make sense here that we can say there is a practically significant difference because Verizon, if you go over to the marginal and conditional, Verizon has only people experience rarely dropped calls is about 90% compared to a little more than 50%. All right, this is kind of the good category right here. Yeah, I have AT&T also. Don't worry, it's all right. It's all right. It gets the job done for $30 a month. So I like what I pay. That's all the AT&T ain't going on right here. 50 points for those AT&Ts. But Verizon has a big difference right there. This is the good group right there. You want to be in the rarely dropped calls. There's not a never dropped calls, but you would want to see this much larger. And you can see this. We are comparing the what distributions of AT&T and Verizon. Keyword right here. We're comparing the what distributions by looking inside of one of the X variables. Great review questions. Review. This is the what distribution inside of these variables. These are the what distributions. By saying, given someone has Verizon, given someone has AT&T, these are what distributions, which allows us to look at the practical significance of this, to say, is it practically different? Like, is there some important difference we should be looking at after we do statistical? Not quite sampling. It's setting, boom, right there, wits in conditional. It's called a conditional. And then what is the other name for the things on the outside? Just review questions right here. We always like to review. Over here on the outsides, we have two what distributions. Within the X's, we have conditionals saying given someone has Verizon, given someone has AT&T, then we can look for all people, what is the percentage drop calls, or for all people, what is the cell phone provider? And just think, it is a categorical variable, and think it's on the outside of the table. It's on the what of the table. So the one I haven't read right there is in the what's of the table. So it's the blank distribution because it's in that. It's the blank distribution. And it's for all people for one variable. Think it's on the outside. It's in the marginal distributions. So you have right here the marginal distributions, and then on the inside of an X variable, you have conditional distributions. Those are conditional. Good review questions right here, just practicing our knowledge. Hence why hashtags show up to class, practice that knowledge, and know these key terminologies right here of a marginal distribution is in the margins of a table. Conditional distributions are when you set a condition like given someone has Verizon, what's the probability they have rarely dropped calls? So we have right here statistical versus practical significance. Once again, very quick review of this. Just like the day. Oh, I like that right there. Veda some 50 or Megan Veda points. Megan 50 points. I can't speak. When we talk about statistical significance, what's the only thing you care about? What's the only thing you care about? You hear statistical, it's a yes/no question. This is review now. The only thing you care about statistical, you just say, show me the what? Show me the p-value right there. You're going to ask, is the p-value less than 0.05? It's a yes/no question. And all you're going to do, Mo? Sure. Yes, Mo. You're going to look at the p-value and say, is the p-value less than 0.05? If the p-value is less than 0.05, it is statistically significant. If the p-value is not less than 0.05, it is most statistically significant. So make sure to know that statistical significance is just p-value. Now, practical significance is the hard one. How would you talk about practical significance, which is something that came up during the Pepsi interview, or Pepsi discussion? It wasn't really an interview. Like that right there. 20 points, people having fun today. I'm having the most fun. So why do I care? Veda, great answers. Exactly. It's why do I care? Like, do I care about this? Does this matter? And that is the hardest thing to answer. And what you need to do here is you need to quote numbers. Quote numbers. You need to give me information like we did on the Verizon example where I told you the people for Verizon who rarely experience dropped calls is 89% compared to 54% of AT&T customers. This is a very large difference between the conditional distributions, which leads me to say you probably should have Verizon if you really want to make sure you don't have dropped calls. No one will take your word for it. You need to quote those numbers and explain to someone and make your case and use the numeric backing. That's probably where people lose the most points in any of our classes is they're not backing their decisions with the data. First thing you do is check statistical significance, and then you check practical significance. So make sure statistical significance first, then practical significance second. And everything you're seeing right here is it. This is it. Statistical significance is just low p-value. And then practical significance right here is 100% subjective. And that's what makes this the hardest thing. You can probably argue your way to a right answer on any of them, but you will lose points if you just say yes or no. I want my graders to take off. If you say yes or no, not for practical significance. You're going to have a bad day. Don't do that. P-value. P-value is just what? P-value is 100% what? Anytime you look at p-value, you're just looking at the what of a test. You're just asking, is it likely that this occurred by random chance? You're asking, is it or is it not what? Significant, but very, Andrew, great job right there. Statistically significant. Because the other one is practical significance, and then we have statistical significance. And here's the crazy thing. Check out this. If I were to give you a range of p-values, and the p-values were to go from 0.02 to 0.08, 0.08 is or is not statistically significant, yes or no? Is 0.08 statistically significant, yes or no? So easy question right there. Is 0.08 statistically significant? No. Is 0.02 statistically significant? Yes or no? Andrew winning some points right there from Mo. It is statistically significant. And so what are you left with? What's the answer to is this statistically significant? Is our result right here statistically significant? Yes or no? Never gonna live that down. So what would you say right here? This is, we think the p-value is somewhere between this. That's the answer. It could be, it could not be. Our test is what? By saying our p-value is probably somewhere in this range, our test has come out what? By saying the p-value is in this range, our test has come out as what? You can't tell. It's like, it could be or it could not be. And we'll have a way of fixing this in a second right here. Does this one doesn't come out as inconclusive. Is this test statistically significant or not? Brian's trying to trick you. Is this test statistically significant or not? Brian's trying to trick you. Yes or no, Mo? Is this test statistically significant? I'm trying to trick you. No. Why is it not? I'm trying to trick you. P-value is 1. Parker, great job right there. 50 points. Yes, I'm trying to trick you. Be very careful. I tried to trick you. If I tricked you, it's all right. You get the points too. The p-value is 1. This is very high. And look at the discrepancy. The discrepancy is very what here? The discrepancy is very what? Meaning it's likely by random chance. Like this is a super likely discrepancy by random chance. I know, I got you with the trick right there, right? So the discrepancy is very small, which means the p-value is very high. Remember in the previous one, the discrepancy was very large. And here's a large discrepancy with a small p-value. The p-value there is 0. So here's a small discrepancy with a high p-value. Discrepancies and p-values are inversely related. That's a decent note to take. A discrepancy that's large is unlikely by random chance. A discrepancy that is small is likely by random chance. So here we are with the discrepancy. Oh, these are large discrepancies rather. The graphic for this, which we're not showing, we should show, would probably look something more like this right here because it's very unlikely by random chance, a larger discrepancy. The discrepancy right here is even larger. This is the banner position one we looked at. Sure, it's going to be some large discrepancy. And these discrepancies between these blocks are very unlikely by random chance. So it's always, what is the p-value, never how is the p? Oh, right there. I'm so sorry. Max cracking up at the chat. I love it. So here we are with the discrepancy right here. Now, here's the thing. You don't want to look at this and ask yourself, is this statistically significant? Because you could say like, well, that's not that large. But it is. But it is. It is large enough to be unlikely by random chance. And we could maybe talk about the percent of people who click on position 2 versus position 1. I think there's about a 10% difference right here. And yeah, I think our marketing firm could maybe make some differences on that. We'd look at the data and say, oh, people who click on it in position 2 happen 24% of the time compared to position 1, 14% of the time. You need to go look at the data for this. Oh, I like that right there. I agree. Max gets a quote in the chat right here. Quotes right here from Max. This is quote 102. Quote 102 from Max. I agree right there. Megan, 50 points for suggesting a quote. Quote 102. Max has quote 102 right there. I love it. Moobot should know it. Anytime. I love it. If people swing by and put some of their favorite quotes, especially during Kahoots, like former students will swing by. Especially Andrew Wynn is the best. Nice job. So now we're switching right here between a categorical variable and a quantitative variable. This one's really cool, especially for some football, because if we want to analyze a quantitative y and a categorical x, we're going to see what graphics we're going to get here in a moment. Oh, so many things. So friendship analytics right here. Who would you like to be friends with? And it's unfortunate. I used to look like one of the guys in this. I no longer look as much like him. I used to be able to do the perfect pose like him. I'm going to try to do it, but I don't have the long hair to be him anymore. I became him and then no longer. So the question was, who would you like to be friends with and how much would you rate the friendship potential of these individuals? This dude's sitting in a creek. I don't know if this is like his senior picture or whatever. That just does not seem like something I would like to do in my spare time, is sit in a creek. It is a really nice area though, so I'm props to him for finding that area. We got different measures of nerdiness, professionalism. Oh, we got nerdiness right here. These are quantitative variables on how nerdy are you, how professional are you on a scale like 1 to 5. I know, right? I don't want to do that. So here's the women with the most friendship potential. I like to think it's this burb right here. That burb right here is number 1. We all want burb right there. But these are the women with the most friendship potential. Most friendship potential. These are the women with the least friendship potential. I do notice a trend where selfies are kind of not good. Here's the guys with the most friendship potential. This guy always reminds me, he's number 1 right here. He reminds me of my friend Jimmy Astro Lewis. People used to know him. He was like, everyone knew him at UT when he went to UT. Like I don't know. He was such a, I don't know. I was on campus entertainment board with him and I'll miss him. But that smile right there reminds me of my friend who I haven't seen in a decade. But these are the most friendship potential guys. This guy's totally at a wedding. Hopefully it's not his wedding. I don't know what's going on. But here's Brian Stevens over here. It worked better last semester. And you can see the theme of selfie pictures. Probably, I don't know. Just selfie picture. If you're looking for advice from this class, selfie pictures, not the best. Not going to win. Not going to win. Here's the women who are found to be the most attractive. Here's the women least attractive. Here's the guys most attractive. Once again, Jimmy right there, number 1. I'm sorry, dude. That dude right there, I don't know. Who who agrees with me? I think these two gentlemen are doing great. I think that, like, I just want to be friends with that guy. Reminds me of my friend. Moral of the story: be attractive. But I'm sorry, gentlemen, right here. I don't know. It's just something about and I hope my selfies will be some friends. Well, no. Selfies, no. We're learning the key to life is not selfies. But I don't know. That guy's looking great, looking just on point right there. And then once again, here's Brian Stevens over here. That's Brian Stevens with the long hair right there. Megan's just killing me in the chat. Oh my god. That's a good deal. Okay. Let me tear up here. Brian Stevens right there. Sorry, Brian Stevens. But you are not. You're number one on the least attractive. This guy reminds me of Steve Wusso, my friend Steve Wusso. I'm just gonna name drop all my friends in the chat. What is wrong with Steve Wusso right there? Why are people finding him to be least attractive? It looks like he's out on the lake. I don't know why he's in a maybe that's why. Maybe they're considering third guy is really, I don't know. But maybe, yeah, it's interesting how sometimes people can remind us of people in our lives. But that reminds me of my friend Steve Wusso, who he and I went to a concert together, drove all the way like 2-3 hours. Yeah, it's bad lighting, isn't it? Yeah, all of these pictures have a lot of bad lighting. A lot of them are very bad lighting. The second guy is your cousin, right? I love it. So, once again, here's the thing. Once again, we don't want to be derogatory towards anyone. We're not trying to be mean. I just like to, once again, I call this me because I'm on the list of the not so. I would not want to ask the Reds hat guy about the MJ versus LeBron. Oh no, MJ versus LeBron. Big stuff right there. Who's number one? I don't know. I don't even want to weigh in. I don't want to weigh in. That's too tough. I don't know. I'm just like thinking who I'm picking. LeBron is amazing, but it's MJ. Yeah, a haircut's a big deal. A lot of things. There's a lot of factors. And so that's what we're trying to analyze right here. Brian, remember? So a lot of what we're trying to analyze here is just variation in data. And this is a lot of social psychology stuff, which I actually love. Max, honestly, we'd probably say Kareem Abdul-Jabbar, Larry Bird. So I grew up with MJ. I'm doing it. I'm going outside the dichotomy. I'm going Dennis Rodman is the best ever. Dennis Rodman had one of the best haircuts. Dennis Rodman was the best to watch because I don't care how good you are at basketball. I care if you're entertaining. So I'm going Dennis Rodman, best basketball player of all time. Got all those qualities that I want right there. Awesome hair, crazy attitude, and you just never know what's going to happen. Dennis Rodman, GOAT right there. Brian's putting it down. Dennis Rodman. And he played with Jordan. Probably why Jordan was so good because of Dennis Rodman. Rodman. So we're going outside the dichotomy right there. But with this right here, we're trying to analyze variation. We're seeing why people pick things. And why did Brian pick Dennis Rodman as his favorite basketball player? Which is funny. That's what my brother and I had growing up. Bill Murray. So yeah, did he actually play? So if you're going entertainment, and that's the thing. So how are we measuring what a good basketball player is? And that really goes to the debate. Space Jam, you're right. He wasn't Space Jam. Space Jam 1, maybe Space Jam 2. I haven't seen Space Jam 2 yet. I don't know. You grew up with Space Jam, now you get Space Jam 2, you're a little iffy on it. So how do we quantify these things? And what does it mean to have friendship potential? A lot of these things are sometimes nebulous. So what we have right here is we are going to try to talk about associations. And what is an association? An association is when knowing one quantity tells you something about another one. So we have the association is when knowing one quantity tells you something about another. And we're going to look at the association where an X does what? What do X's do for Y's? What do X's do for Y's? And our X is going to be categorical here. And our Y is going to be quantitative. What do X's do for Y's? What's the point of having an X? X's do what? Getting serious. X's do what? What do X's do? They explain, Kevin, right there. Great points. They explain. X's explain. So X's explain why something is happening. The why is what you want to understand. The why here will be quantitative, like why are people found to be attractive? Why are people found to have more French potential? Why do people think, if we gauge like what rating would you give LeBron, what rating would you give MJ, and then we could say maybe people value these different things. Hey, that's fine. Probably better than Shaq, right? Hey, who's not better than Shaq? Probably I might be. Like your ex. Megan is on point with jokes today. Thank you, Megan, right there. Megan's just on fire today. So we see right here, this goes actually back to Stat 201. We have two different distributions. If you had two quarterbacks here, quarterback A and quarterback B, what would be the difference between quarterback A and quarterback B? I'm going to have to write these in. But if you had two quarterbacks, quarterback A and quarterback B, on the first graphic, quarterback B, which I haven't written yet, would have a different what? On the first distribution, quarterback B would have a different what? Like we're looking at the yardage they get, or like passing average or something like that. That's excellent. Mine does too. So if we look at quarterback A versus B in the first distribution right here, in the first distribution, what do we have going on? The first distribution, what's going on? What's a change in? Hint, shape, center, spread. This is Stat 201 again. A lot of the topics we cover are Stat 201. I tell my Stat 201 students, we're going to be covering this again. We're going to talk about shape, center, spread. They have different means, which is the measure of center right there. Everyone, great job. It's a different center. It's a different mean, also different median, also different modal area. But those are all measures of where the center of the distribution is at. So take a crazy guess right here. Shape, center, spread. What is the difference on these distributions right here? Quite a few measures right here, but they're all measures of what? When we talk about the distribution differences on the second group, we're talking about differences in spread, which is going to have a larger IQR, which is the range of the middle 50%, a larger standard deviation. And since these are normal curves, we probably want to go with standard deviation. Last but not least, just take a crazy guess with shape, center, spread. What do you think is the difference right here on the last set of data? I can't draw. What is the difference here on the last set of data? We have not shape, center. We have center, spread. With the last set, we have a different what for the distributions. Shape, which is also probably leading to different standard deviations and different centers. They might be close-ish in center. Probably medians or means, because the mean's going to skew to the right. The means might be close. The standard deviations, who knows, because they're totally different shapes. The main thing we're going to really focus on right here is analyzing measures of center right here. So the big thing we're going to focus on is measures of center. So we have two measures of center. We have mean or median, and this is where your Stat 201 knowledge comes into play. When we use the average, the distribution should look how? If you use the average, the distribution should look more what? Comparing that to median, and this is huge for the test. There are test questions, hint, 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 that are derived pretty much from this. It can look uniform, more normal, more symmetric. Uniform probably is one of those like iffy ones, which I did draw uniform 100% right there, David. I'm sorry, I didn't mean to trick anybody. More normal, less skew, less outliers, more normal. Like the better the normal, the better the use of it. But right here, we're looking at when we would use the average versus when we would use the median. And we use the median generally for things that are not normally distributed, especially when what? So maybe I'll draw the quintessential examples right here. These are your quintessential times to use them, as in the like top times. Got to use those big words like quintessential. Like these are your top times. When there's outliers, when there's skew. Great job right there, Megan. So you have a choice of your center right here based on, is it normal looking or is it not normal looking? Like normal, use the averages. Not normal, use the medians. So we're doing a choice right there. And so we need to be able to test this now. So when we do this test right here, guess what we're doing? We are once again doing a test on the averages or the medians. Once again, just repeating the same thing. Brian goes over these things a few times right here. When we are using the means, the data is roughly symmetric with no extreme outliers. Pretty much normal. When we are using the median, we are having skew or outliers. There is skew or outliers when medians are used. So that's really your choice. You look at the data, you figure out if it should be means or medians, and these are both measures of what of the distribution. Stat 201 here for 20 points. These are both measures of what? The mean or the median will tell us where my head is at. The mean of the mean will tell us the center. Megan, great job, Megan. Exactly. It'll tell us where the center's out of the distribution, the middle of the center, the central tendency. Here we see the normal distribution. The mean and the median are in the same spot. Do people ever take the average of the mean and the median? That'd be interesting. They don't. Maybe Max, find out if they do. I've never seen that in the literature. There's other ways like mean ranks, which is what we call non-parametric ways, like non-distribution based. And then that'll be less impacted by skew. But sometimes you might do both. People could compare both and look at a robust method to outliers. Robust means outliers are not going to impact as much. So a test on medians is not going to be impacted by outliers. So you say it's robust to outliers, just terminology you might ever hear. So really what we're looking at here is the normal distribution. Good stuff. How do we know if something is normal? In Stat 1, we have a great name for this. It's called a normal probability plot. It's a plot that shows you the probability something is normal. Read it backwards. We see if it follows the bell-shaped curve. And this will be a QQ plot, which is a normal probability plot. It stands for quantile plot. It plots the observed quantiles versus the expected quantiles. So it's just matching up like, here's what we observe and here's what we expect. And do they follow each other? So we're going to see the quantiles of what we would expect, which just shows us at this point we're this much through the data. We observe that. And then does it match with what we expect? Now, once again, I can tell you what these are, or I can show you, and we can do examples. So here's what a QQ plot looks like. This is a QQ plot, also known as a normal quantile plot. It's plotting the quantiles of what we observe in the data versus what we would expect given it's normal right here. This red line down the center is exactly what we would expect. This is your perfect normal. Nothing is perfectly normal. You are not perfectly normal. No one's perfectly normal. And if you were, that'd be sad. So this is what we see. And is that distribution? Don't look at this. 100 points in the chat. Everyone starts spamming. Don't look at the histogram. Don't look at the histogram. Don't look at the histogram. That's where people are going to make mistakes on the test. That's where we trick you. Don't look at the histogram. Is that data normal or not? Is this good enough right here? Is this good enough? And I'll show you why you don't look at the histogram. Don't look at that histogram. Don't look at that histogram. Is this data normal or not normal? It's normal. Follows it well enough. Let me ask you this. Is this data right here normal or not normal? Parker, I know some sand quotes right there. You can't trick me with some Star Wars. Parker gets second quote of the day. Something that innovative gets... I know some memes. Parker's got quote 103. Let's take a vote, or let's take a bet. We haven't done betting in a while. I wonder if people know how to bet. So betting, normal. And option 0 is no. You can bet up to 100 points. And option, so this is bet, exclamation point, option, and then which one you want. So you have to do 28 people. Oh, God, I should never looked at that. People not attending are going to not know how to do any of this. They're going to not know what any of these QQ plots are. They get to the test. Make it Mo, I would have. So is it normal or... Yes, or I'm so sorry. I can't make it Mo now. Here, wait. Can I edit this option? I can't edit it. I might have to explain it. No one wants to bet. This is why I hate histograms. You are correct. The answer's in the code to if it is normal or not. Got someone going out on a limb here. The answer is in the code. The code answers whether or not it's normal. 3, 2, 1. I saw one more bet come in, did not? Oh, switch it around. It's bet and then it explains how to do it. So it's bet the ID and then the amount. Bet the ID and then the amount. Bet ID amount. So you have to make sure so it's bet ID and then amount. Bet ID and then amount. We're ending in 5, 4, 3, 2, 1, 0. I'm a little in the future, so I give it a second more. Oh, dang it. This is not a normal looking histogram, but the data is normal. Histograms have in them breaks. It's how many bins you're doing. This is the same data. I'm just changing the number of bins. So this is a stat to a 1 thing where I'm just changing the bins of the data. I can change the bins to anything I want to make it look ridiculous or make it look like it kind of should look. It'll have defaults right there. But the way to really look at this is with a QQ plot. To do a QQ plot, you have to go to reg classes where we have the QQ plot, and you just do QQ of the variable you want, and guess what? Does that follow the red line pretty well, yes or no? Does that follow the red line well, yes or no? Nice. What could have been? Today is all memes all day long. This follows it. That means it's pretty normal. So you generally want to see it generally follows it, but be careful because you can get stuff that kind of goes away from it. You can have ones that are kind of like, I'm trying to get one that by random chance has a little bit outside. Now, you don't want to see something like this and be like, aha, we got extreme values. It's just random chance. You can get, look here. Uh-oh, not normal, right? Is this normal? Yes, or not normal? No. Is this normal? Yes, or not normal? No. Is this normal? Yes, or not normal? No. Yes or no, is this normal? Yes means it's normal. No means it's not normal. The answer is yes. This is still normal. I'm actually using the same code to generate it. It's just that these are by random chance a little bit odd. So every once in a while you'll have, every once in a while you get a little bit of odd. What you really want to see when you're looking to see if things are weird is you want something, don't look at the histogram, don't look at the histograms. You want to see something that really deviates. This is good evidence of non-normality. Now, I know I'm looking at the histogram here, but that is connected to that portion. If you look at the portion that's mostly normal, it does follow the red line. If you want to see something that looks even crazier, look at this. If you told me this was normal, I'd tell you you're crazy because this is such a departure from that red line down the center, and the data is so heavily skewed. Take a look at these extreme outliers here, which show up. These are the observed values up here at 5,000, which are the values down here. It's weird how it does a flip, but does that make sense? What you're seeing right here is it's showing you what you observe, and what you observe is way higher than what you would expect given it's normal. So this is like, that looks nothing like what I would expect given it's normal. Anyone else see the... Oh, this? This is the face right here? Is that the face? Is that the face of the... I don't know. Going crazy. The little merp... I don't know what's going on. Does this data look at all normal? Top right? Oh, I do right here. That dude face. Oh my God, I didn't even see that. That top right face. 50 points. Noticing things Brian doesn't even notice. So is this is not normal at all. This is what we expect given it's normal. And no. Not normal. Probably want to use medians right here. Just to be safe. You throw some medians. If it's not normal, just use medians. That's about your biggest thing right there. So that's what we're doing right here is we're figuring out, do we want to use means or medians? And once again, if your data looks a little bit weird, you're all right. The more weird it starts to look, I cannot unsee it. Once you see it, you can't unsee it. It's like I tried to draw a face and it wasn't nearly as good as that. So when we compare these right here, box plots would compare the medians. This is a big deal right here. Sorry, my glasses, friends. I wear glasses in the evenings sometimes because I'm old. I've actually had 2 eye surgeries. But interestingly enough, glasses... I don't know why, and I don't know if this is real. Like, I mean, this is real data. Teacher did it with real data. But apparently, glasses is one of the biggest differences in friendship potential. You want to go out and make friends, take off those glasses. I mean, you'll be blind. Maybe that's why people want to say, hey, you're blind. Can I help you out? Like, I don't know. I say that because I'm pretty blind. Take my contacts out. Whew, not a good day for Brian. Is there a method for assessing multiple centers? And yes, we're going to look at multiple centers right here. Yeah, don't go out blind. It's not a good idea. So here we are. We're looking at the means, and the means are being shown. Now, here's one of our biggest codes. Here's one of our biggest codes right here. Who can explain the general format of this for 200 points? What is the general form of this? You need to know this. We literally were doing this in 474 today when we used the aggregate. Your glasses deserve better than this. Maybe there's an interaction. Maybe there's an interaction that we've left out, that glasses are good in certain scenarios. Maybe it's like if you have friends who have glasses there. I don't know. I'm sorry. I'm a glasses wearer. I started wearing contacts at like 12. Y tilde x comma data equals. Y tilde x comma data equals. I said 200 points. Didn't I? Got to hit the 100 point twice. Y tilde x comma data equals. When I throw out crazy points, it's something you should know. That format right there is y tilde x comma data equals. We're seeing if a parent race explains someone's friendship score. And there is some small associations right here. I think it's due to random chance. We'll see more on that in a moment. Here's some more associations, just looking at it, but we're going to go ahead and look at the data right here. So we don't put tests. If I do something quickly, it's probably because it's not the major stuff on the test. When you look at this right here, sometimes we have data that is so heavily skewed, we want to pull in those extreme values by taking the log of it. So if you look right here, we're doing a log function on the y with an additional argument. So this is basically y tilde x comma data equals, but we're throwing in a log function, which is really nice. So you can log the y variable here pretty quickly. And I was even doing some graphics last night that were logging it, just because you have extreme values. Y tilde x comma data equals, very important right there. Oh yeah, fantasy team right there. I did see that, yeah. I was showing Chelsea the fantasy names, and then the commit on the team, or how I commit your mother. She saw that one and was like, that's really cool. Because I was telling her the fantasy team's doing pretty good. I think you won, right? Y tilde x comma data equals 1, right? I think you won, Max, I think. I saw there were some. I was towards the middle of the pack. There were some high scores, like 150. It was a big week. It was a big week. Oh, you're How I Commit Your Mother? Yeah, I saw it. Chelsea liked that one. That was like her favorite. And then she's like, is there someone on their team named Komet? And I was like, I don't know. I don't know the names of players. I just look at the stats. I don't know sports. I just run numbers. If I knew sports, I'd be a lot better. But I just run numbers. So what we're doing right here is we're doing an ANOVA. So we are doing an ANOVA, which is an analysis of variance to look at the variation between each of the groups. Now, we have what we expect via random chance and what we observe in our data. So I want you to see this very important equation, which will be on your assignments. Hint, hint, hint. We have right here the F statistic. The F is a discrepancy. Put that in chat for 50 points. The F is a discrepancy. The F is a discrepancy. The F is a discrepancy. It's a discrepancy. It's like a difference we have right here. So the F is a discrepancy. The F is a discrepancy. Nobody even knows that. Of what we observe over what we expect. If I tell you, I will pay you $10 an hour to grade $10 an hour to grade papers, but then you end up getting 110. You observe that. Is that a big discrepancy? If I pay you $110 an hour and you expect to get $10 an hour, is that a big discrepancy? You expect to get $10 an hour and I pay you $110 an hour. So that would be a discrepancy of 11, and it's a standardized way of looking at a difference. But what if I tell you, I will pay you for a whole semester $1,000 or $10,000? I mean, $10,000 for a whole semester, not bad, right? I will pay you $10,000 for a whole semester of grading. We'll delete this one. So I'm going to pay you $10,000 for a whole semester. So that would be what? I tell you I will pay you $10,000. That would be the what value when we run this. I tell you I will pay you $10,000. From those two values I've listed over there, is that the F, the O, or the E? It's the expected. You expect to make $10,000. But get this, you're going to get, instead of $10,000, you're going to get $10,100. Now, that's nice, but what would you say? That's kind of close to what you would. So think about the previous one where it was you expect $10 an hour and you get $110 an hour. This one you expect $10,000 and you get $10,100. So what do you notice right here? Cool bonus. You're like, it's not a huge discrepancy. So now the discrepancy right here is at 1.01. Is that the F statistic? It's very close because you're actually getting something very close to what you expect. It's not that unusual. And i.e., it could just be by random chance. Had to do it. That's exactly where we're going with this with the ANOVA. The ANOVA is what we observe in the variation between the groups versus what we would expect in the variation between the groups if there's no association. How can we get the expected variation if there's no association? The expected variation with no association is probably just when we do what to the results. The expected variance between the groups is probably close to what when we do what? When we do it randomly right there, Megan's correct over there. When we do it randomly. And when we have a small F statistic close to 1, then that means there's probably no association because these two values would be very close to each other. These two values would be extremely close if the F is 1 because then we're observing what we expect due to random chance. So we want to see that the F statistic is generally bigger. And when the F statistic is bigger, what do you notice here? Go back to your previous wording. This is a bigger F statistic, and this is smaller F statistics. I told you that the F is a what between the groups. You see in the second graphics where there's a strong association, a larger F statistic, there's more of a what between the groups. You could, an F super close to 0, great answer right there, question. An F super close to 0 would look like this because Brian's trying to draw something where there is what down here on the bottom. My drawing down here on the bottom where the F is basically 0 is because we have what? Think about the top part of the equation. There's what between the groups. There's no variation between the groups. Nathan, great job right there. Another 20 points to chat. The F of 0 would be obtained when there's no variation between the groups, and that is like no association. This one should say no evidence of an association or strong evidence of an association. The larger the F, the stronger the evidence of the association. The smaller the F, the less evidence of association. The smallest possible F is 0 because to get the 0, you'd have to have this equal to 0. That there'd be no observed variance between the groups. So if you literally have both groups at the same level right here, they're even across, which these are not perfectly even. It's just very small discrepancies, close to what we would expect. So does that make sense right there? What the F statistic is? If the groups perfectly were to line up, there'd be no discrepancies, i.e. the observed variance between the groups is equal to 0, so 0 over anything is 0. If the F is close to 1, then it's kind of what we would expect due to random chance, and the larger the F, the larger the discrepancies, and thus we observe, here's a good hint, we observe 26.794 times the variation between the groups. It's a factor. We observe 26.794 times the variation between the groups than we would have what by random chance. We observe 26.79% more or times more variation. It's a factor. 26.7 times more variation between the groups than we would have whatted by random chance if there's no association, than we would have expected. And that sounds like a lot to say that there's that much more variation between the groups than we would have expected due to random chance. Nathan, amazing work today. Great job. And so here's interpretations of the F right here. An F of 1 is what we generally expect. An F of 5 is pretty large. Now, when is the F large enough? We have to create random permutations, and we're back to where we were a moment ago. We have to create random permutations to look at what would happen if we randomize these. Now, if we randomize these, a lot of the F's we record via the permutations will be very what? By random chance, and we're just randomizing them, the discrepancies between these groups will be very what? We're going to repeat this a lot. We're just going to keep randomizing it and recording the F statistic by random chance. A lot of these discrepancies by random chance would be very what? A lot of these discrepancies by random chance would probably be very what? Very small, exactly, because it's just by random chance. We're just saying, just mix them up. That's what we're doing right here is we're just mixing them up. Here's our observed data. And look, there's a pattern maybe in the observed data. And then we are just mixing them up, just a permutation. And the best way I like to say this is I walk in with your tests and I do what with them? And I say, pick up the closest one near you. So I walk in with your tests and I do what with them? And I say, just pick up the one nearest to you. So did you study? Yes, yes, no, 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 yes. And then your grade, throw them down the stairs. So I walk in, I throw your tests up in the air, and I say, pick up the one closest to you. So then whether or not you studied, If there was an association between your grade and studying, it would be just due to what? If I throw the tests around, I just say pick up the one nearest to you. If there was an association between studying and your grade, it would purely be because of this. It'd be because of chance. Does that make sense what permutations are? It's just randomizing the variables, so it doesn't, anything we see is due to random chance now. And that's what we're doing right here. This is a really great way of doing modern statistics because we're simulating what would happen if this was just due to random chance. And then the most important thing we're going to look at is our observed data, which is going to tell us what we see and if what we saw was unlikely. So now comes the big question. When we do the analysis right here, should we use means or medians? Really big questions right here. Should we use mean or median and why? This is a big question, and this is where people get stuck on the test. Mean or median and why? 100-point question. Try to solve this one. Should we use means or medians? And why? The why is important right here. Means or medians and why? Exactly, Megan. You can show with data right here. So means or medians. And you are correct, David. How are you making that decision? You are correct. How are we making that decision? I'm on top chat, so I need to be on live chat. No wonder I've been a little delayed. Yes, Wilton, perfect answer. Wilton got definitely those points. Wilton's looking at the QQ plots down here, and this is where you want to look. This is what we were reviewing earlier. Make sure to look at your QQ plots and see if it follows this red line. Both follow it pretty well. That's a little bit of an issue, but whatever. Does that make sense, Max, right there? We were saying, I think, Max, you got it right here. We're looking at the QQ plots. Looks pretty normal. Good to go. I want to say a huge thing. This stuff is brand new stuff that we're doing. People are going to be like, QQ plot, what the heck? It looks close to that line that fits the normal curve, so it looks pretty accurate. Don't look at the histogram. Megan, another 50 points. Don't look at those histograms. They're just there to trick you. Don't look at the histograms. I think they're really skewed. The histograms will show up, but don't look at the histograms. Oh, no, Max. Max, 20 points. Don't look at those histograms. So right here, some of the points are outside the bands, but it's okay. We're going to use means. Now look at this right here. The differences between the means, which is going to be right here, is likely what? These differences, which is the practical significance, and here's every bit of statistical significance. These differences between the means is probably what? You know what's going to happen right here. These differences between the means is probably what? First thing to look at, not statistically significant. Probably just due to random chance. We see that it's 1.5 times more than we would have expected. Interpretations for your assignments. Just plug in your numbers, and you got an answer for how to interpret the F statistic in the notes. Hints, hints, hints. So that's a good interpretation right there for your assignments. And then, is this practically significant, yes or no? Very actually quick answer to this. I said you can't say yes or no, but because of the first question we ask here, the answer for this is a little bit easier for the second. I mean, you could give a little detail on why it's this, but the answer is no. Because it's not statistically significant. Since it's not statistically significant, it can't be practically significant. Exactly, Wilton, right there. You're exactly right. It's not statistically significant. The first door you have to go through. Then you can talk about practical significance. So, no. What is the red line again? These are things we should know. What is the green distribution? What is the red line first? Interestingly enough, that's about 22% or something. The red line is our observed discrepancy. That's where 1.5 is at. So if you remember looking at the F statistic of 1.5, the green is going to be the random permutations. Max, don't worry. Max and 50 points. I like it. I don't know how to spell permutations either. My spelling's horrible. Yours is probably better. And then the green is the random permutations by random chance. And then the shaded area above or outside our result as extreme or more extreme than ours, that is the p-value. So the p-value here is large enough to say that it's likely by random chance. This doesn't mean it happened by random chance. It just means we saw something that is likely by random chance. We don't think there's something really going on right here. When we test the medians, these are some extra slides we don't need to look at. The medians is done the same way, but most importantly, we should know that the median is done when there's outliers or the data is what? i.e. the QQ plot does not look very good. The medians is when the data has outliers or is what? Like the most important thing to know from this slide is use medians when the QQ plot comes back showing it's not what? I've thrown out a lot of blanks. There's skew, there's outliers, it's not normal. That's the most important thing to know. We don't have to do the calculations on the medians. There's no assumptions. We just use it when the data is not normal. That's what it's talking about here. And it shows the calculations, but we've never put this on the test. So if you don't come to class, you might be reading through this notes and be like, man, this is a slide with a lot of numbers. No, don't look at it. So when we look at the p-value right here, the p-value for the medians or the average test is going to tell us if what we saw was unlikely by random chance. Now, this p-value, and this is what people just go crazy about, is it's actually estimated. It's estimated by the number of permutations we do. So you don't usually get a p-value of 0, but when you get a p-value of 0, it means that you had no discrepancies as extreme or more extreme than yours. We're seeing right now what? Who can explain what this test is doing right here? Just explain to me in words what this test is doing. Then we'll look to see if we should use means or medians. What is this test doing in words? So what are we trying to understand right here? Just explain to me. Remember how the format works. Y tilde x comma data equals. So we're trying to understand what right here with what. Nathan, great answer in the chat right there on that. Is there association between the day of the week and the quantity of, and the tip percentage someone gives? And so I like that right there, Nathan, great answers. I'm throwing Nathan's 50 points. I would say, does knowing what weekday it is help us explain the tip percentage someone gives? Does that make sense? I'm going to put a little explain on the weekday, a little salt-based explain on top of that. And then over here, like why somebody tips a certain percentage. It's important we have like which one in the X and the Y spot, because does knowing what weekday it is explain to some degree the tip percentage someone gives? And you might say, well, there's differences. You'd say, man, that Friday, getting some good tips. That's the highest average tips. And Saturday, low tips. But these differences between the groups, say it with me. Those differences between the groups are probably what? Don't copyright claim me, Monster Cat. They did one time. Are you confident about that or not confident? Here's where people get confused on the test, because that's Stat 201. This is BAS 320. Down here on the bottom, we're into the BAS 320 way of talking about it. And are you confident or not confident? Are you like, yeah, I'm pretty confident? Are you confident or not confident? The way this would be read right here, what I've highlighted would be read, you know, I think the p-value for this is somewhere between 0.426 and 0.515. I'm 95% confident the p-value for this test, like the actual real p-value, exactly, David, 100-point answer, the whole interval is above 0.05. What do we not want to see in that interval, which would lead to confusion and would lead to us having an inconclusive result? When we run these intervals to estimate what the p-value is, we do not want to see what in that interval, because then we're confused. We're like, and you would say, isn't 0.05 a good thing? But we don't want the interval to be partially above and partially below, because then it's like, well, maybe it is, or maybe it's not, and our result would be inconclusive. So say it with me, every one of these intervals is above 0.05. Every one of these intervals is what on the test? Every one of these intervals shows a what result on the test by being completely above or completely below 0.05. These are all completely above. So all of these results are what? Regarding the statistical significance. All of these results are definitely this. C word. It is not inconclusive. Conclusive. Every one of these is not statistically significant. So these are not statistically significant right here because they're all above 0.05. And then these results down here are conclusive because the intervals do not contain 0.05. This is a major point of confusion, and get ready when we start reviewing. People will wonder, wait a minute, when is a result conclusive? A p-value interval is conclusive when it what? A p-value interval is conclusive, good note to have. A p-value interval, when we do an interval for the p-value, is conclusive when what? Good note to have. A p-value interval is conclusive when it does not contain 0.05 in the interval. So it could be completely below or completely above. And if it contains it, it's not conclusive. If it does not contain it, it is conclusive. Does that make sense right there? You don't want it to have 0.05 in this interval down here on the bottom, because then you're not sure if the p-value is above or below. Conclusive when 0.05 is not contained in the interval. Exactly. So it could be completely below or completely above. And up here, you're just looking at Stat 201 p-value knowledge. So this is the 201 way, and this is the 320 way right here when we talk about the conclusivity of the interval. What do we mean by contains 0.05? Aha, this right here. Do you see these numbers right here? Does that contain 0.05, yes or no? So then you just look at that, what I've circled right there, and you say, does that contain 0.05? And it doesn't, so it is conclusive. I'll show you an inconclusive one here in a second. I think we have it in the notes coming up. Is this interval right here conclusive or inconclusive? So the p-value up here is not statistically significant because it's above 0.05. So then is that interval right there conclusive or inconclusive? We've gotten through all the notes. It's just review and graphics at the end. We got 9 minutes of examples. Is this interval conclusive or inconclusive? And why is it inconclusive? Which means it can't, it's not sure. It's like, I don't know. Think about being inconclusive. 0.05 is in the interval, then it's like, I don't know, maybe it is, maybe it isn't. If you go down to the low side, maybe the p-value is below 0.05. Or does that make sense? Maybe it's below 0.05. I don't know. It could be as low as this. So yeah, maybe it is significant, or maybe it's not significant. The result came back as insignificant, but I don't know. Maybe it is, maybe it isn't. Who knows? I mean, it's not, the result says it's not, but we're not so sure about that result. Now, to contrast that, we've got a different result right here with this one. What I just highlighted right there, is that statistically significant or not? The one I just highlighted in blue, just going by p-value, only p-value here is the p-value. So we want to look at, is it, here, I'll explain, Daniel. I think this will help with it right here. So that is statistically significant, right? And then right here, is this interval conclusive or not conclusive? So is that one, is that interval right there conclusive or not conclusive? The second one we're doing right here, I'm just going to show only that. So that is statistically significant up there because p-value less than 0.05. And why is it conclusive? Why is it conclusive? Yep, we can go over that here in a second, Matthew. You got it. And why is it conclusive? Why is it conclusive? And that's what we're talking about right now, Matthew. Max, good question right there. It does not contain. So it needs to be either entirely below. So this is conclusive. So this is conclusive because it is entirely above or below. It does not contain 0.05. Why is this interval on this previous slide right here? I'm going to show just it. Why is this interval right there conclusive? Oh, I deleted it. Why is this interval right here conclusive? Why is that interval conclusive? Why does it come to a conclusive result? It doesn't have 0.05. It can be entirely below or entirely above. Why is this interval right here? Well, is this interval conclusive or inconclusive right here? When we're estimating the p-value right there, we think it's somewhere between 0.031 and 0.071. So when it comes to knowing if it's statistically significant, that interval is what? Conclusive or inconclusive? And why? Inconclusive. Yeah, Daniel. That's what you keep doing examples. Sometimes I found the best way sometimes is just hammer in examples, just like example, 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 example. You just look at the interval and you say, is 0.05 in there? So it can be completely below, as in highlighted in yellow. It can be completely below, or it can be completely above. You see right here one that's completely above. You just don't want to see 0.05 in the interval because then it's like, I don't know. So this one is not statistically significant, but conclusive on that result. Does that make sense? It's not statistically significant, and it's conclusive. This one over here is or is not statistically significant. And then we'll talk about the ANOVA, and we'll talk about what's on the screen here. This one right here is or is not statistically significant. First off question, is that result statistically significant, yes or no? Yep. I think Daniel's getting even better. So if it's completely below, it's conclusive significance. Completely above, yep. Daniel. Yep. Daniel, 100 points. Yep. This would be statistically significant inconclusive, because this one right here is where you decide whether or not it's statistically significant, which it is, or not statistically significant. This only decides the conclusivity of it, which this is inconclusive right here, inconclusive. So this is inconclusive down here. So you just look to see, is 0.05 in the range of what p-values might be? And if it is completely below, then obviously the p-value that's estimated is going to be between these intervals. So the only way to get an interval that is completely below is to have a p-value that's below 0.05. Great job right there, and that's the practice we need. So one of the questions was, what's the difference between these tests right here? Now, we only do 2 of the tests. There's another non-parametric test on the screen right here. I'm going to put it in red. We don't use it, but you could if you wanted. We won't on our assignments. There's the mean ranks test, which is the Kruskal-Wallis test, or just the Kruskal, excuse me. Well, the Kruskal-Wallis, yeah, Kruskal-Wallis. We don't use that test, so you really have 2 choices on here. You either want to compare the means, which is the ANOVA, or you want to compare the medians. And why are you going to choose between the means or the medians here? And then you have the medians for each group listed out. Why are you going to pick between the means or the medians? Why are you going to pick between them? Based on the what of the data? How would you choose the normality exactly? So really you're picking between these 2 to say, do I want to look at the means or the medians? You do get the mean ranks for the fun of it, just because that's coded into here. We're only going to look really at means or medians, and the means is the ANOVA. ANOVA stands for analysis of variance, and it's looking at the variation in the groups and comparing the means between the groups to the overall mean of the distribution and seeing if there's differences. So what we're really looking at with an ANOVA right here, if we do the calculations in the background, is we're looking at the means of the groups. So you can see right here the overall means. This slide does a good job of comparing it. So when you look at the overall means of everything, you can then compare the distributions to each other and look at the variation between the groups. Here's where this group is centered at. Now, these means are a little bit different from where they're at because these are medians, but you can see that the differences here between the means are larger than we would expect. So the variance between the groups, an analysis of the variance, which is variation between the groups. This one has little variation. This one has more variation, and you're just comparing like what is the variation between the groups, and this one has a larger variation between the groups when we standardize it with the F, which is just a discrepancy, where this one has a smaller variation between the groups, which is close to what we would expect via random chance. We have the observed variance between the groups, which is the differences right there between the hashed lines, and the predicted variation for what we would expect due to random chance. So we see very, very close numbers to what we would expect. With our example we were just doing, should we compare means or medians? The closer the F is to 1, the closer it is to what we expect, and the larger the p-value. And do you think we should compare means or medians here? I can tell one is normal without looking at a graph. How do we tell if something is normal? How do we tell if something is normal? Good question. How do we tell if something is normal? We use the means if it's normal, but how do we tell if something is normal? And the answer is these don't look so normal to me. I'm thinking a little more than what I like. A little more. This one's okay. This one's great. This one gets happy face. That's great. QQ plots for normality. QQ plots for normality. Taking away his nose. I don't know. Eraser. So QQ plots for normality. And really, the last distribution over there for Thursday, you can tell it's normal because of the way it the more here 1 minute timer on the clock before we end class, going through the last minute right here. Right here, we'd probably compare the medians, and the median test comes back inconclusive. So when you do these results right here and you're looking at this, before you pick to compare averages and medians, what must you look at? We might. I'm going to throw out 100 points right here. Stay till the end, remember. We got seconds on the clock. Before you choose to compare means or medians, what must you look at? What must you look at? Before you compare means or medians, what must you look at to know which test to analyze the results of? The normality, and you'll do that how? The QQ plots. Great answers right there. And I think that does it. We start on time and we end on time. If you have questions, let me know. That's excellent work today, everybody. Big class, lots of information. And I want to keep saying this. I'm so worried. I know we're in this home stretch. Gosh, the world's just on fire. Man, I feel bad. I want to say this. If you're having a tough time, please reach out to student services, the dean's office, or something. I work with all accommodations. If life is just crazy, let me know, because I've been around UT for 10 years, and these last 3 semesters or so have been some of the craziest. Or 4. Spring, fall, spring, fall. I kind of feel bad for anyone who, I hope the world gets a little more normal, because I kind of feel bad if people, like, their whole college experience is this. Well, I mean, I like this. I like this. I like this. But I hope, you know, not just for like college experience. I want the world to be more normal again. And so, but if you're struggling, let me know. Reach out to student services, reach out to the dean's office. I really mean, there's a lot of people at UT who care, and I know sometimes it feels like people don't care, but there's a lot of people who care at UT. I've seen it time and time again. And if an instructor or something ever doesn't work with accommodations, I'm very sorry for that, because that's not the way it should be. I work with all accommodations. So, you know, that's my biggest goal, is to, like, hopefully help students use the resources that are available. I don't know, it's just a crazy semester. Craziness. But we'll put the main screen back up. You got this. Make sure to keep hashtags showing up. I was like, oh no, I looked at the attendance today. I should not look at such things. Never look at the attendance, Brian. Look, we get people at the start. We got 35. We had 36 people watching at one point. Do we still have 28 people? Thank you if you're still here. Might not still have. I don't know what happens. We have like 75% attendance. Class is over, right? Oh, Engineering Expo. Okay, that makes me feel a little bit better. You're welcome, Megan. Excellent work today, Megan. Great job. Megan, 100 points goes out to Megan again. Bringing that lighthearted, bringing that fun. That's what we want to do. We want to keep it fun. We want to keep it lighthearted. Enjoy our time here. And, you know, what fun is... What's the point of class if you're not having fun, you're not learning? So we got some great examples today. Had some great jokes. Got some great quotes. And... Oh, Wilton right there. I like that for some 20 points. I just give out 100. I would have given out 100 if I didn't just give out 100. But yeah, no, good stuff. We're going to have some office hours here soon. So swing by if you want to work on the assignment. All that good stuff going on. Lots of work. Gosh, I was like, what day is it? I was like, it's Tuesday. We do have some tutors, I think. Maybe we should look through the Discord, or I should put a message out on the Discord and say to people in like 474, 475, 479, be like, hey, you know, are you interested in tutoring 320? We could set something up. But the earlier you start, like, getting a tutor and everything, the better. Good stuff right there. So we should probably put some messages out on the Discord and make like a sign-up sheet and take a look at that right there. Awesome stuff. Yeah, Alyssa, write me in the Discord and be like, hey, Brian, can you send out a message? We could probably try to make a sign-up sheet. There's a lot of really, like, there's a lot of people I'd pay $10, $12, $15 an hour to get some tutoring. Oh, thank you so much. I appreciate that. I thank you so much for your kind words. There's a lot of really kind and understanding people too. I promise you, like, maybe I'm just such an extrovert that I'm glad people feel that way about me. Because I really do care about all my students, and like, I want to see everyone succeeding. That's tough because I've got 900 students. If you're round up, it's probably like 860 or something. But everyone, vols help vols. I couldn't agree more. And vol means all. Vols help all. It's tough. It's tough. And every student who I think doesn't do as well as they wanted to, feel bad. Because I want everyone to do as well as they feel they should do. Like, if you're like, I'm going to make an A, I want you to make that A. If you're like, this class is hard, I'm going to make a B, I want you to make that B. Maybe better. Yeah, it's tough. And if I can just tell you one last thing here, one last bit of advice. I think one of the hardest things for us to do, and this is not how we conquer everything in life, because there's bigger problems that we need help for. Reaching out for help is a very important thing in life. To know when you need help and ask for help is probably one of the best things we can do. And that right there is the extra effort we need sometimes. So if you need help, reach out, ask for help. Once again, I'll try to help as many people as I can, as many ways. And yeah, so let's do that. I got you. You got me. We got this here on Stat Tool and BAS 320, all of our classes. I'll be doing office hours here in a little bit. Swing by. Reach out for help right there. We got this. Office hours in like 15 minutes. I'll talk to everyone later. Bye.